Hello and welcome to this video lesson. In this video lesson, we will be looking at how to determine the point of intersection of two functions graphically. Alright, this is one of the easiest methods of actually solving for the point of intersection. And what we do is we have two different functions and we simply graph our functions or relations. And then we graphically determine the coordinates of where they meet. So let's try this out with an example. So in this example, we have two lines, so I will use two different colors. I will use blue for my first one, and I will use purple for my second one. So my first one over here is y is equal to 3x minus 2. In this case, to graph this, first of all, I will just label y and x. My slope value is the coefficient of x, which is 3. That's same as 3 over 1, meaning that the 3 is my rise and the 1 is my run. And my slope value is my y-intercept is negative 2, meaning that I have a coordinate of 0 and negative 2 on my graph. So this is my origin right here. Point 0 and negative 2 is right over here. And from this point over here, I know this is one of the points on my line. So then I know my rise is 3, so I would go up by 3, and my run is 1, so I will have a point right here. And then I will do that again, and I will get another rise of 3 and another run of 1. So if I do that multiple times, I will get a few points, and then I can start drawing a straight line that goes through all of these points. And you will have a ruler to do a better job. So, and especially when we have two lines, we always have to label them. This is y is equal to 3x minus 2. Now for my purple line, y is equal to 2x. So here my slope is the coefficient of x, which is 2. That's same as 2 over 1, meaning that the 2 is my rise and the 1 is my run. So now, in this case, my b value is 0 because this is the same as 2x plus 0. So that means that I will have a point on my graph, which is one of the points that lies on this line is the point 0, 0. So that's this point right over here, right at the center. And my rise is 2, so I would have to go up by 2 and run by 1. Up by 2, run by 1. Up by 2, run by 1. So I can actually graph this out, and once I do that, I get a straight line that looks like this. And you can see already where they intersect. This is exactly where they intersect. I will just use a different color to show that. It's right here. And I can then go and find the coordinate of this point. So from the 0, 0 point, I have to go right by 2 to get to this point, and I have to go up by 1, 2, 3, and 4. So the point of intersection, POI, is at point 2, 4, and I will box my answer over here. And that's kind of all you have to show, except I'm missing one little thing, which is the label for the purple line, which is y is equal to 2x. So if you are given a question like this, where you already have a grid and you have the two, then all you need to do is draw out your two graphs and then figure out at what point they meet, and then make sure to write the point of intersection there. So just to put a few check marks, you need to have proper line and label. Make sure your line has your arrows on it. You need to have line and arrow for the other one. and you need to show where your point of intersection is at. And make sure you actually box your answer there so we can easily figure out where that point of intersection is. And here, if you do these parts, these are implied method mark, which are actually really helpful, especially if you make some mistakes in your drawing. Then actually showing this work that you understand what the slope is and what the y-intercept for both lines are is actually very, very useful. Not every two functions will have only one solution. So you will have cases where lines are parallel, and if they're parallel, if one of my lines was the purple one, my second line will be parallel to that and go like this, and they would go like this forever, infinitely long, and they will actually never meet. And if they never meet, we will say that these two lines have no solution. So you can say that they have a zero solution, because if they have a zero solution, you might mean that they have a solution at 0.00, but it's best to word it as no solution. If two lines are coincident, that means that they lie on top of each other. All right, let's do an example over here. So this example says to determine, so I need to show all my work, the point of intersection graphically. And I get two functions. One of them is y is equal to negative 2x plus 3, and one of them is y is equal to 5 minus x. So try this one out on your own first, and then you can pause the video and then resume it again to see the solution. Alright, I am going to use two colors. I'm going to use blue and I am going to use purple. My blue line, y is equal to negative 2x plus 3. I want to graph this one. I have a grid, so I will use my grid and I will say that my slope is negative 2. That's same as negative 2 over 1, meaning that this could be my rise, or this could be my, and this could be my run. And my b value is plus 3, meaning that I will have a 0.03 as my y-intercept. So I will start at my y-intercept over here. Rise by negative 2 means that I have to go down by 2, and run by positive 1 means that I have to go to the right by 1. And I will do that a few times because that's my slope. And once I have enough points to kind of draw a nice line, I can actually draw a line that goes through all the points. And again, once you have a ruler, this is a lot easier to do. And I will make sure that I have labeled my graph over here. Once I have my blue lines, I will have to draw my purple. Y is equal to 5 minus x. My m value is the coefficient of x, and in this case, my coefficient, or what's being multiplied by x, is negative 1. Negative 1 is same as negative 1 over 1, meaning that my negative 1 is my rise, and the 1 is my run. My b value over here is my constant value. In this case, it's the value of 5, meaning that I will have y-intercept of 0, 5. So I will start at 0.05. And from this point, my rise is negative 1 and my run is positive 1, meaning that I will have points that go like this, and then I will connect all of my points, and I should get a line that goes kind of like this. And again, with a ruler, this is a lot easier. And you can see that these two actually intersect right at this point. So I will label this as my point of intersection. I will look to see what the coordinates of that is, and I can see that will have to move left by 2 from the y-axis, so the x value is -2, and for the y value you have to go up by 1, 2, 3, 4, 5, 6, 7 from the origin, so my point of intersection is -2 and 7. And I will box my answer over there. And also label this as y is equal to 5 minus x. As an extra step, you can actually check your solution and make sure that it works. So to check what you would actually do, you would actually take the -2, which is your x value, plug it into both equations, and see whether you get 7 both of the time. So check x is equal to -2. So for my first equation, y is equal to -2x plus 3. So if x is -2, I get y is equal to -2 times -2 plus 3, which is 4 plus 3, which is equal to 7. And that's fantastic because my y value is 7. So this equation checks out, and my other equation, y is equal to 5 minus x, so that is equal to 5 minus -2, which is same as 5 plus 2, and I'm getting that -2 comes from this, and I'm plugging this into here, so this becomes plus, and I get 7. So in both cases, when my x values for both of the equations, or when my x coordinate is -2, my y coordinate is 7. So that actually checks out, and it makes sense that my point of intersection will happen at point -2, 7. To show your work, you can get some implied method marks by showing your slope and y-intercept. You need to show your final answer and make sure you box it. You need to show your line plus its label. You need to show this proper line. Actually, you need to show this proper line and proper label as well. Alright, so sometimes you get a little bit larger values, and when you have larger values, it's a little bit more tedious to actually draw things out in a grid. And sometimes, like this example is the example we started with in part 1 of point of intersections, when we're just introducing you to where it can be used and kind of like a real life example of it. And in this case, we have 7.5 as our slope, and it's just a little bit more tedious to actually draw that on a grid. So a lot of times when we have real-life problems, we actually use a graphing display calculator, or we use technology such as Excel, spreadsheet, or something along those lines to actually solve the problem. Now, I have attached links to the description of this video of how you can use your TI-84 and TI-Nspire to solve for point of intersection. So depending on which calculator you have, make sure you watch those videos and make sure that you learn the procedure, because usually during a test situation you're not given the instructions on how to use your calculator. You got to be an expert on that on your own. So make sure you watch those videos. If you're using a different calculator than TI-84 and TI-Nspire, then please make sure that you type it out on YouTube and figure out how you can find point of intersection using your calculator. And once you know the procedure, I just want to show you what you need to jot down in kind of like a assessment situation. So when somebody is looking at your work, they know that you kind of understand what you're doing and you're not randomly spitting out answers. So in this case, if you remember the example, y here is representing the cost of the tickets, and the total cost of all the rides, and x is the number of tickets that we're buying, and 10 is the price for each ticket in plan A. And for plan B, we're paying $100 fee first, and then every ticket now costs $7.50, and y represents the total cost. So once we put this in our calculator and we solve for the point of intersection, then to show our work, what we do is we say using GDC, or Graphing Display Calculator, or different technology. You can say spreadsheet if you have that option, depending on your school. What we do is we draw a sketch of the situation. And this sketch comes from your calculator. So the 10x in this case will look something like this. And you need to label this one as y is equal to 10x. And you need to do plan B as well. Plan B's equation doesn't have as much steepness, but it does have a y-intercept. And it goes, and this one over here is y is equal to 100 plus 7.5x, and they meet right at this point over here, and this point over here is your point of intersection, which is at, I think it was 40 and 400. So this is kind of like the solution that you need to show. So you need to say using GDC. So let's actually put some check mark over here. So this is method. You need to accurately show one of the line plus the equation. You need to show the other line accurately, and you need to show its equation. So label, label. And you need to show your point of intersection, and obviously you need to have your x and y axes over there as well. So point of intersection, you can highlight it, and that would be another accuracy mark. Depending on what the question is, in our example for the real life problem, the question was how many tickets does it take to have the same cost. So based on how we label things, we said that x represents the number of tickets and y represents the total cost. So you do need to actually have a concluding sentence for this one and say that when there are 40 tickets, or when you go to 40 rides, or you can word it differently depending on how you labeled your x and y, the cost for both plans is $400. So you do need to also have a concluding sentence over here mentioning what your x was and what your y was. So to really show your work of how you're solving the problem, you need to make sure that you include a sketch of the work. And the sketch here is this portion over here. So you need to include that sketch and then have a final concluding sentence. And if it's not a real life problem, and if the question was simply asking you to figure out the point of intersection for y is equal to 10x and y is equal to 100 plus 7.5x, and it wasn't given to you in a context of a real life problem, you don't actually need this concluding sentence. You just need to highlight this section over here which says your point of intersection is at 40 and 400.